Remember, when you are solving a system, you are looking for where the curves intersect. So you know that's a parabola. You know that's a line. How many places do they intersect? 2, right here, these 2 points. Easy. All right, directions stipulate substitution. Okay, now in the real world, you can solve it however you want. We're even going to learn a new method in this chapter. But right now, substitution. So what's going to be your strategy there if we're going to use substitution for this system of equations? Okay, so if you're doing substitution, a very smart move, well, a necessary move, is to get one of the variables by itself so that you can plug it in to the other equation. So since x is sitting there all by itself, pretty much, it doesn't have a coefficient or anything, she said just add y to the other side, and then we can rewrite this second equation, 3 plus y minus y squared equals 3y. What are you going to do with that? Well, eventually I might factor it, but before I factor it, I probably better clean it up. So I'm going to get 0 over here. I'm going to add y squared. I'm going to subtract y, and I'm going to subtract 3. You have to get your equation set equal to 0. You can move everything to the right or move everything to the left. You know, I confessed my personal problem. I can't factor with a negative square, so I'm going to move everything over here so it's positive. Now, if it factors, go ahead and factor it. Looks like it does. So again, I'm going to get 2 different answers. I'm going to get a y value of 1 and a y value of negative 3. Is everybody keeping up with me? So what do I do now? I go back and plug it in. So if I plug in the 1, I'm going to plug it in right here. I'm plugging it in for y. You can plug it in wherever you want. I'm going to plug it in here because it's easiest. That gives me an x of 4 and an x of 0. Is that okay? All right, next. Again, we're doing substitution, so force yourself to substitute, even if you wouldn't normally, with this problem. So if we are substituting, what are we going to do first? Add the 3y over here. We got to get something by itself, and it makes sense to get that x by itself. So then I'm going to take this and plug it in here. I'm doing substitution. So this would be your approach if you were doing substitution. We could clearly use a different strategy if we wanted to, but the directions, we're going to follow the directions. All right, so let's do our distributive. So negative 12 minus 6y. Uh-oh, uh-oh. Uh-oh, what's going on here? Yeah, and you're left with, what you are left with is the important part. You're left with negative 12 equals 4. False. So what does that mean about these 2 things? They're lines. What does that mean? It means they don't cross each other. These are parallel lines. Remember, when you solve a system, you are looking for where they cross. This one we did over here, we had a parabola and a line. They crossed in 2 points. That makes sense. Here, that's nonsense. They do not cross. There is no solution. So we have parallel lines. Okay? Now, since they're lines, you can literally write parallel lines. If they're not always going to be lines, though, so you would write no intersection. No intersection. There are no points of intersection. All right, one more substitution, and then we're going to move on to elimination. Again, you've done this so many times in your life, your old hat at this. What do you want to do with this one? How about set them equal to each other? Can't we just set them equal? So 1 plus 2x minus x squared equals 1 minus x. Now we're right back to where we were a second ago. Got a quadratic equation, so we're going to move everything, get it set equal to 0. I'm going to add it all over here, so I'll have x squared minus 3x. Is that it? What do I do with that? Take an x out. Bingo, you factor. Only factoring is different this time. All I can do is take out an x. So what does that tell me about my points of solution? There's 2 of them. X is 0 or x is 3. Now come right up here. You can plug it in anywhere. Let's plug it in the easy one. So 1 minus 0 is 1. And 1 minus 3 is negative 2. Anybody have a question about substitution? Easy. Okay, same kinds of problems now. They look basically the same. But now we're going to do elimination. What is the premise of elimination? With substitution, we get a variable by itself and plug it in to the other equation. What do we do with elimination? We make, sometimes elimination is called addition. You're going to add these equations together, and when you add them, you want to lose a variable. You want to eliminate a variable. So it usually involves multiplying by something to make that happen, because right now, if you added, they wouldn't cancel. So we're going to have to what? What do you want to do? What? Top by 2? If you do the top by 2, you have this equation. Remember, all the way across gets times by 2. And then on the bottom, you have this. Now, when we add, these are going to cancel. So we get 5x equal to 15. And x equals 3. Then you got to go back and do exactly what you did before. Doesn't matter where you put it in, but somewhere in here, you have to put in a 3 for x. And I got 4 for y. Did I do that right? Yep. So your answer is 3, 4. They cross at 3, 4. Isn't this a great way to spend our time? We're eliminating, we know how to do this, it's so fun. All right, try the next one on your own. This one's got a little bit of an additional challenge. For this one, you're going to have to multiply both equations by something, would you agree? So you can make anything up there match you want, but you got to do it right.
So basically, would there only be like 2 different answers when there's like an x squared or y squared?
Yep. Yep, lines can't cross in more than one point. All right, so go ahead, get started. Make it happen. Anybody have an X or a Y yet? What do you have? -2 for X, that's what I got. Good, I got -2 for X. I got 3 for Y. Yay! Good work. One more elimination problem. Here we go. Last one. C. Okay, go ahead and give this one a shot. Same thing, elimination. A little easier. What happened here?
All reals?
Everything canceled. Now, what I want you to pay attention to, though, is this is different than what happened before. What happened before, I forget what the numbers were, but we got something like 4 equals 17, right? Okay, there's a huge difference here. This is no solution. 4 never equals 17. This means they are the same line. There are infinitely many points of intersection. They are the same line. Now, please don't say all reals, because it's not every point in the whole wide world. It's all the points that are on one of the lines, right? These are the points that are the answer. Not every point, but they're the same line.
So you just put like same line?
You're right, same line.
And
Yep.
like parallel line?
They're parallel lines, if they're parallel. Now, guys, again, does everybody see the difference between losing the variables and getting 4 equals 17 and losing the variables and getting 0 equals 0? All right, because that's going to come into play with our bigger systems also. We have more equations. Okay, all right, let's do number 3 and see what happens. Now, notice that number 3, I haven't told you how to solve it. So you're just going to solve this system however you want, whatever occurs to you. So does anything occur to anyone?
Divide y on the second equation.
Here, so x equals 300 over y. Now she's choosing to do substitution pretty much because it's her only choice. There's nothing really to eliminate. So she says, I'm going to solve this for x. So then I'm assuming you're going to come up here and plug 300 over y in for the x value. Everybody still with us? All right, so remember, multiplying fractions straight across. So this is 600 over y plus 2y equals 100. What in the world?
Y over the other side?
So we're going to multiply everything by y. I think that's what you said after what you meant anyway. We're going to multiply everything by y so that we don't have a fraction anymore. So we're going to have 600 plus 2y squared equals 100y. Remember, when you multiply everything by y, you multiply everything by y. What's that? That's another quadratic. So I'm going to get it set equal to 0. Now, everything there is divisible by 2, so it might make your life easier if you divide it by 2. It's perfectly legitimate. It's certainly not required, but it does make your numbers a little bit smaller. They're still pretty big. Now look. try to factor it, and if you see the factorization, go right ahead. If you don't see the factoring, and I don't see it right now, maybe if we played with it a little bit, we could. So if I can't see how to factor, I guess I'm just gonna use the quadratic formula. I have a calculator, so I don't care how big those numbers are. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So underneath there is going to be, oh no, I don't think it does factor. Did you get 1300 under here? Now that does, that's not a perfect square, but that does break down. How does the square root of 1300 break down? Isn't it 13 times 100?
What is it, 10 root 13?
10 root 13. If you can see a perfect square in there, like 100, take advantage of that. Don't think you have to break it all the way down to all the infinitely many factors. What about that now? Is there anything I can do with that?
Simplify it.
Take a 2 out. So it looks like I'm going to have 25 plus or minus 5 root 13. You're not gonna like it. That means there's 2 answers. And what was that? That was, oh shoot, I erased my problem. So that means the y values are 25 plus 5 root 13 and 25 minus 5 root 13. Those are the y values. And then x is 300 divided by y. That's what we said in the very beginning. So my x values are going to be 300 over 25 plus 5 root 13. What in the world do I do with that? Multiply it by the conjugate. You know what you mean. 25 minus 5 root 13. Lordy, lordy, lordy. So what's on the bottom? 625 minus 25 times 13. So, oh, wait, we're almost done. Hang on. What's 625 minus 325? And that's going to cancel with that. So my x value for this one is 25 minus 5 root 13. Or, is that 13? Now when I do the other one, the only thing that's going to change is this is going to be a minus. So these will be pluses. Won't all the arithmetic be the same?
Yeah.
So that one's going to turn out to be 25 plus 5 root 13.
Yeah.
Whew, that was a big one. But we did it.